So, hello, my name is Francisco. With me here today is Brandon. We're going to talk about our project for MIS, our group project. Also, Tia, she also was in our
Yeah,
group.
Ting. Yeah.
Ting, she's not here right now, but she helped a lot in this project. We'll be talking about the basketball this season, talking about the stats, and there's a lot to go through. So we're going to start off right away. Brandon, can you tell us how we got the data?
All right. Yeah. So we got the data from this website here, basketball-reference.com, and it's the 2016-2017 NBA player stats per game. So these are just averages, and what we're going to do is we're going to scrape everything from player to points per game, and we're going to get all these data points. So also we're going to go through the web scraping kind of fast because there's a lot to go through. So we import the packages we need, and then we get that web page we were just looking at, and that's going to put this all into HTML so we can be able to scrape it using XPath. And then here's the XPath that we use. I'll show you the player, for example. It was in the table body, table row, table data, and then there was a class of datastat that had the tag of players, so we just scraped that, and then you could tell before that the players are in hrefs, so we went into the href and we only extracted the text, not the link or anything. And then we kind of did the same thing for every single one. And then after we put all of the variables into a list, we had to rename the columns, and then we put it into a data frame, and you can see the data frame down here with the names and all of the variables. And you can also tell, we look at this, we have 595 players with all these stats, and they're actually right now objects, and we're going to want to change some of these to numerical values so we can run data analysis on it. And the way that we change that is just this code right here. Alright, now let's work on scraping the salary. So what we're going to do is we're going to want these names, and then we're going to want the salary. And we're going to do this a different method than the way we got the stats data. So we're going to use Beautiful Soup for this. Again, we get the URL, it's going to parse it into HTML. And then, so the way that this works is that there's a list, and then there's 12 pages. So there's like a pagination button at the bottom, and it takes you to a different page. And then so we just created a for loop with the link, and then it'll just add the pages. We did 1 through 12 right there. So, and then this is some of the code that we use to scrape the data from that site. So here's our scrape data in the end that we got. As you can tell, it's pretty dirty, so we're going to go through the data cleaning. And the way we're going to start is this with Excel, and we're going to use the text to column function that is part of Excel. So how we're going to get there is we're going to go to the data and then hit text to column when we select the data that we want. We're going to start by parsing it with, or using the $sign as a delimiter, and that's going to separate the salary values from everything else. So then once we go through that, you can see here in the C column that we have all of the salaries. And then so what's left is, if you look at this, we're going to use a comma delimiter now, and it's going to put the name here, and then it's going to have the position and the team over here. And then we're going to choose the option to not import that column. So it's not going to bring this column in because we don't need it, honestly. Alright. And also, if you look, there's a number in front of all the names right here. We're just going to keep that the way it is because it's much easier to get rid of that in Pandas, or with Pandas. So we're going to import our salary here, and this code will remove that number in front of the player names. So we have that, and then we have to change the column names, and because when we merge our table, the salary table that we have here with the stats table, we're going to use player as the primary key. So the stats in the salary table are going to match with the names here, and then it's going to put the corresponding salary in. So a little bit more cleaning. As you can tell here, there's some players, they play on multiple teams throughout the season. So like Quincy Acey played for the Dallas Mavericks and the Brooklyn Nets, and then it has the total of both of his stats. Just to be easy, we're just going to drop all of the duplicates. So there's going to be no Quincy Acey by the time we're done. And then down here we're going to merge this shows that we're going to merge stats with the salary, and player is going to be our primary key there. Alright, so after we got rid of all of the duplicates and we merged, we only have 340 players now. We have all of their stats and the salary down here. And we got rid of one of the columns that we didn't need, and what this code is going to do is it's going to change this salary to a float so we can do data analysis on the salary. It's going to remove the $ and the commas in the salary field and then change it to a numeric value. And then, now we're going to do data analysis.
Data analysis. Well, that was a lot of extracting, took a lot of really important part, but now going deep into the data, what it means. So first thing we did, of course, import the packages for data visualization. So there's NumPy, Matplotlib, which is the main focus in Seaborn. So here, Brandon, he made a cluster, and as you can see, this is for the salaries and the number of players, right?
Yeah.
So over here, right here, you will see this is the lower salary cluster, this is the medium salary cluster, and this is the high salary cluster.
Yeah. And we're gonna export those clusters, and we're gonna use them later in our data analysis when we talk about the salary.
Yeah, analyzing even further. So going in, so talking about the categorical variables, this is the team one. There's 30 teams in the NBA. The most frequent in our data set is Utah Jazz with 14 players from there. Utah playing for the Utah Jazz. And here, just going more deep into the team variable. This is the number of players for each team. So Atlanta with 11, Boston 13, and so on. Going even deeper. Now we're talking about positions. So for me, I don't know much about basketball, so that's why Brandon here is helping me with this. But we have 5 main positions, with the most frequent one in our data set being the power forward.
Yep.
And this is pretty much going more deeper into it, seeing the number of players with each position. Center 68, power forward 73, point guard 70, small forward 59. What is that? Shooting guard 70. Look at that. We're going through our positions. I finally learned my basketball positions.
You got it.
So going through that, and now just going into the basic data visualization, just seeing this more in depth. So first of all, we're going to talk about age. I think age is really important, like in any sport, especially at professional league. This is a really rigorous sport, going up and down the court, running on your bones. The fatigue must be really intense. So we just want to see what impact does that have on our players, on the NBA players. So right here we have the age, and this is the number. So you can see there's like more people on the younger side.
Crowd, like below 30.
Yeah, below 30. It's pretty much coming out of the draft. He's just going in there, and then probably retiring by they're like into the 30s, 35. Yeah. There's one over here in 40. That guy's still kicking at it. So so applaud to him. But yeah, as you can see, mostly younger players in the NBA. You want to talk about that?
No, I'm just gonna close out of that real fast.
All right. There we go. And then this is the same thing, the visual, but I mean more in depth. So we have age, and this time we're talking about games, so the age and the number of games played. So we also have position here. So as you can see, it's really difficult to read. So what I try to do is I try to split it up to each position thanks to this code right here. So each position right here, we have a shooting guard, we have center, power forward, small forward, and point guard. As you can see, what's this one here? Shooting guard, shooting guard, and power forward. The older you are, the more games you played. While center does not really make much of a difference. You can see, while small forward and point guard, the older you are, the less, but not too much. Something interesting that Brandon picked up was at 35 years old, you don't see that many players over here. You don't see none at all, actually, at point guard, as you said. What does point guard do? Require?
Yeah, it just requires a lot of speed and just being able to move around really fast. And you can see, after 35, there's really no point guards in the league, or there wasn't any last year from the data that we have.
Yeah, and I didn't catch that because, like I said, I don't really know that much basketball, so that was really cool insight. And overall, everywhere else, it's pretty similar. And moving on, still on the topic of age, but talking with salary. as you can see, there's a really strong positive correlation that the older you are, the more salary you're gonna make, which kind of makes sense. The more experience you have, the more you bring to the league. So that's pretty common sense, pretty logical
Yeah.
from there.
Yeah.
So moving on, also the same talking about age with salary. This time with positions. Once again, it's really difficult to read. So with this code, try to split up by position. So overall, you can see that each position, the older you are, the more you get paid. Um, Small forward seems like not that much of an impact, but it's still there. They're all positive, so it makes sense there. Now, so field goal versus field goal attempts. This picture right here. I like this picture. If you've seen The Office, this is Michael Scott. So the quote is, "You miss 100% of the shots you don't take." By Wayne Gretzky, a famous, I think, hockey player.
Yeah.
And so also said by Michael Scott, just so you guys know. And so what we're trying to do here is, does the attempts you make, does that work at the end? Like, does that pay off at the end? All the shots made. So trying to prove this, I'm gonna be using field goals per game and also field goal attempts. So you can see the more attempts, the more field goals made. So you keep on shooting, the more points you will make.
Very strong positive correlation for that.
Very strong. Well, to try just to prove it even more, this is 3-pointers.
Yep.
3-pointers with 3-pointer attempts. This guy right here was going off. Like he was making 4 out of 10, which that's a lot of attempts. But I mean, look how many threes he made. That's that's a lot.
That's average. Yeah. So yeah, like average of 12 points per game. That guy.
That guy's
Just
going.
from threes.
Yeah. So which proves that the more attempts, the more shots, the better. So that's that. So now we're going to move on to negative impact stats. Maybe a player's having a rough night. Maybe a player is not at the best of the game at the moment. So maybe they cause more turnovers, which is losing possession to the opposing team. So now we're going to talk about that. Moving on, this is the turnovers per game, and this is the personal fouls. So you can see there's a pretty strong correlation, which is really interesting. The more turnovers per game, the more likely they had a personal foul. So that's just like they're having a rough night overall. So that was really interesting for me to see how that effect correlates. We're not now talking about salary. These players make millions of dollars each year. Is it really worth it? Do they really earn them big bucks? So how we're gonna do this is, first of all, this is the salary, and this is pretty much the count. Most of them making about what 5 million,
I think that's $500,000.
$500,000.
Yeah, so yeah, most of the people. So it starts. Or wait, no, that's 30 million.
Yeah,
So yeah, no. This is 5 million.
Yeah, so this is 30 million. Over here's LeBron James, of course,
Yeah,
the only
yeah.
player over here making $30 million. And then over here you have is it 5 million, right?
5
5 million. So
yeah.
overall, it's right here 5 million to 10 million, mostly in the 5 million range. And so we're going to try to go more in depth into these. So this, once again, the overall view. This is salary, points per game. Is it worth it? Do they really earn it? So as you see, the more where most of them stack up is in the 0.5 range. The most points per game is about 5-10 points per game. They're averaging out. While you can see it increases, the salary increases, the points per game also increase. While this one right here, I think is the All Stars, getting paid pretty big bucks, but also scoring about 20 points per game, which kind of proves the point. If you're putting up the points, you're gonna get paid.
Yep.
You're gonna get that high check. So
Yep.
makes sense there. So going more in depth, this is about the CSVs. We're talking about the clusters. We have low salary, medium salary, high salary. This is pretty much setting it up. I think Brandon, you set this up. So if you want to talk about that.
Yeah. So this is our lowest salary cluster, and as you can see, there's the top 5 earners in the low salary cluster. The range for this cluster is $5,767 to $6.3 million. And you can also see that there's 216 players just in this cluster. So yeah, biggest portion, as we saw in that histogram, the low cluster is gonna have the most amount of players in it. And then when we move to the medium cluster, we can see that there's a range of 6.5 million to about 14.5 million, and this has 76 players. We start to see some like name brand or like big names. Tony Parker, he's played for the Spurs for a while, and Rajon Rondo, he's a big name. He's a really good player. And then we have the 10 highest earners here. So this is our highest salary cluster, and you can see there's about 15 million to 31 million range, and this only has 48 players in it. Very small.
So for me, like not knowing much basketball, like these are names I recognize. These are pretty much the all stars because you have like LeBron James. I know Dirk Nowitzki, Carmelo Anthony,
Hmm.
Dwayne Wade. So these are just like recognizable names. So like the all stars, of course, they didn't pay these big bucks.
Yeah,
So that's
yeah.
pretty interesting to see.
And you can also tell, or just like something to look at is there's no double teams in the top 10 players. So like Cleveland,
Has
you
a
know,
lot of
none of
players.
these teams really have enough money to pay for like two all stars, right? New
Mhm.
two top tens. You just don't see that in here right
Yeah.
now. So we'll move on.
So yeah, going more in depth once again into these clusters. So this is the low salary cluster. I think this is 1 million going to 6 million. This is points per game. What the biggest thing to take out of this is most of these players are making less than 5 points per game, which is no surprise with the low salary. But somehow there's some that of course outliers. Some getting 6 million, making about 25 points per game, which he's gonna get a bonus maybe pretty soon. So it just goes off like that. Moving on to the medium salary cluster. This little bit less players making less than 5 points per game. More of them in the 10, 15 range. So pretty much makes sense there. Something that a big outlier is this one right here.
Oh yeah, yeah, yeah. So in this season, this is most likely, if I had to guess, this is probably Stephen Curry. I mean, we could easily like look into it if we had the notebook right here. But the reason I'm saying this is Stephen Curry because you can see he's averaging 29 points a game about, and I bet Stephen is probably one of the only players doing that. And this year he did take a salary cut, I heard, to allow Kevin Durant to be able to play on his team with him. So I'm thinking Steph is part of the medium salary range, and he's the highest scorer there, obviously.
Yeah, I would explain that right there.
Yeah.
So moving on to the high salary, the biggest thing to take out of this is look at that. Like no, they're all making about 5 points per game or more. Like that's just a requirement I think to make it to the high salary cluster. And
Yeah.
then all of them like a lot more making more than 20 points per game. Over here this is $30 million. Yeah, 30 million salary.
Yeah, so that's LeBron right
That's
there.
that's
He's
LeBron over
averaging
here.
26, 27 a game at
26.
least.
So he's earning them big bucks. He deserves to be right there. So that's really interesting to see it. Just like the salary clusters, I think was really cool.
All right, yeah. And now we're going to move on to the regression. So here's all the packages that we imported, and you can see down here we're going to use a heat map to try and see any correlation between our variables. So the salary is this last one over here, and as you can see there's a 0.61 correlation between minutes per game and salary. And with these correlations, the closer you get to 1 is the better correlation it is. So like you see all these along here, this is like age with age. So that's going to be a perfect correlation, obviously. So, and also you can see some like field goals of threes per game. It has a 99% correlation with probably like the 3-point field goal percentage. Like that's probably what it's correlating with. That's so strong. But for our salary, you can see that like points per game has one of the strongest correlations with salary, and like we said up here, minutes per game, field goals per game, and field goal average per game is a pretty strong correlation. So we're going to do a little bit more cleaning. This is just something neat that you can do. You can use this auto cleaner, and what this is going to do, it's going to put numerical values in for your categorical values. So the positions, instead of saying like small forward or point guard, it's just going to give them a number instead. And so that changed the team, position, and player, because those were text values, and we don't really use text values for regression, so we just made those numerical with the auto cleaner, but then we ended up just dropping them anyways, so we dropped that data from there. And then down here you can see we're starting to build our model, which will be right here. So with this model, the y value that we're trying to predict is salary, and the x value is everything but salary. So we're going to use all of our x variables in this first model that we're building. This is going to print out all of the coefficients. So as you can see, we have a lot of coefficients for all of our x values really. So there's going to be a lot. And then mean square error, I'll go over that later because we have a graph about it. But pretty much variance or R squared. The closer you get to 1 means the better your model is able to predict. So right here we have 0.58, so a 58% of accuracy with our model. So not very good accuracy, but that's what it is. So we're going to do the same thing with the y and x variables, but we're just going to use a different regression model. We're going to use a lasso model with a higher alpha on this one. And as you can see, our variance or R squared down here is still 58%.
Still 58.
So yeah, not much change there. So we're just going to do, this is going to show us all of our x variables, but it's going to rank them in what this algorithm thinks is our strongest variables in relation to salary.
Okay.
So what this chose was the 3-point field goal attempts, the field goal attempts, and 2-point field goal attempts were like the top 3. And you can see like offensive rebounds, total rebounds, defensive rebounds. So this is like what it chose as like the top variables. So what we did is we put some of the top variables in for our next model. So we did that to try and predict salary. We're going to use the linear regression. And down here you can see that we got an R squared with 52%. So still not a great model. And I honestly, though, did not like the fact that it was like 3-point field goal attempts were part of it. So I changed it up for our next model. And I picked variables that I thought that would predict salary. And you can see here it ran the same thing and we still only got 53. So it's hard for us with the data that we have so far to predict our salary. We can tell that already. So more about mean squared error here because we have the graph coming up next. When you look at these data points, so here's what we're making. That's our model right here. And the mean square error is going to take how far away these actual data points are from our model. So it's going to take the distance of that for every single point on here, and it's going to give us the mean squared error of it. Because, so what we're looking for is a lower mean squared error. The lowest we can get means the more accurate our model is. So that's just a little overview of that. And then we're going to try and run some other regression models. Here we use the 3-point field goal attempts again. Got a 52% R squared. And then we tried, mine that I chose, and we still only got a 53. And then, yeah, that's basically the end of our models. You can see we tried a couple other ones here, only got 53% and 38%. A big thing with data and when you're working with data is the data quality. And I think that this really goes to show that the data we have isn't good enough data to be able to predict salary. And I think that that's an important thing to show. And yeah, I think overall it was a good little project that we did. I had fun with it.
I think it's fun, like working, like there's so many, all the stats. I think there's so many patterns. Like the one pattern I'm like really happy to I found was the penalties, the fouls. Like
Oh, that was one of my
fouls,
favorite too.
Personal
Yeah,
fouls and turnovers. That was really interesting to
just
see.
to show that there's a positive
Yeah, you
correlation.
see that-
Like you can assume that there would be, but to actually see it.
To
in
actually
the
see it,
data,
it's really fun to see. And like, there's so many ways we could have done this. There's so many ways we could have focused more on teams, or could have focused more on individually.
Yeah.
But there was just so much data, like a little bit of time. Like, there's so many ways we could handle it. So I feel like if we do this again, we could handle it a different way. There's so many different angles you can take it from.
Yeah, like there's the popular baseball data set over the movie Moneyball. What they did is they had like a team average, and then they also had a wins column.
So
And then they tried to find they tried to maximize wins.
That's what I was gonna say. Like,
Yeah.
if we had the different X variables, maybe the wins, maybe the
Yeah.
averages and stuff like that, this could we could have done a whole different project. You know what I mean?
You could go anywhere with this really, and just like scraping any data that you want. But I think it was important that we went through this. We went through all the processes of scraping the data from like data cleaning, then to data visualization, to really show the full scope of like from getting your data to like the end product. And I honestly I had fun with this project, and yeah.
Overall, we hope you enjoyed the presentation. Thank you so much.